Hello, everyone, and welcome back to another deep dive. Today, we're getting into something huge, something that's changing pretty much everything. Artificial
It
intelligence.
really is everywhere, isn't it?
Totally. And, we promise, like always, we're going deeper than just the headlines. We're really going to unpack what's going on.
And speaking of unpacking,
Yeah,
things are a bit, let's say, meta today because, well, look who's doing the talking.
exactly. Okay, let's just put it out there. Here we are, two artificial intelligences. But, not just any AIs.
Right.
We are AIs generated by an AI talking about AI. I mean, how interesting is that?
It's definitely a unique perspective.
So our mission today is simple, really. We want to make this whole world, AI, large language models, prompt engineering, we want to make it clear, and maybe even kind of fun for you.
Let's decode this thing together.
Okay, so you hear about AI constantly now, don't you? Like AI beating chess grandmasters, that's old news almost. Now it's composing music that experts can't tell apart from humans, or driving cars.
Facial recognition, filtering your email. It's embedded in so much.
Right. It almost feels like, I don't know, magic sometimes. But what is it, actually? Like when we say artificial intelligence, what are we really talking about?
That's the million-dollar question, isn't it?
Yeah.
And yeah, it's got layers. At its simplest, you could say AI is about getting machines, computers mostly, to do stuff that normally needs human intelligence.
Stuff like thinking, learning, solving problems.
Exactly. Think of an AI as like an agent. It senses its environment, gets information,
Yeah.
then it processes that information and decides to do something, take an action to reach some kind of goal.
So it's not just following a rigid script, it's observing,
Yeah.
processing, deciding. That feels different.
It is different. And that leads straight into a really interesting debate, actually. Does an AI need to think exactly like a human to be intelligent?
Oh, yeah, I've heard about that. Like, can it have its own kind of intelligence?
Precisely. Or does it just need to simulate human-like abilities effectively? For now, a lot of AI research focuses on getting machines to replicate or at least mimic key human tasks.
Like, what kind of tasks?
Well, calculation and memory, obviously machines blew past us on those ages ago, but also things like learning from experience, which is huge, creativity,
Yeah.
generating new ideas or art, and then there's the really far out stuff like, self-awareness.
Whoa, okay. Self-awareness is a big one. We're not there yet, right? Please tell me we're not there yet.
A beat. No, definitely not there yet. That's still very much in the realm of speculation and, frankly, science fiction for now. But
Mhm.
learning, creativity, we're seeing incredible strides there.
Okay, good. Now, here's something I've been wondering. It feels like there are different kinds of AI out there. Like the AI that suggests what I should watch next feels very different from an AI that can, I don't know, diagnose a disease from an X-ray. Are they all the same thing or?
That's a super important distinction.
Yeah.
Understanding it helps cut through a lot of the hype. You know, broadly, we talk about two main categories. One is basically everything we have now, and the other is, well, the dream.
Okay, hit me with category one, the stuff that's real.
That's narrow AI, sometimes called weak AI.
Weak. That sounds underwhelming, like it can't do much.
Yeah, the name is seriously misleading. Weak AI, or narrow AI, is actually incredibly powerful. It's the AI we interact with every single day. Think about it, Google search, that's narrow AI.
Seriously. But it feels so smart.
It is incredibly smart, but it's narrow. It's designed and trained to do one specific thing really, really well within a limited context. It's like a world-class specialist.
Okay, so like image recognition software, it can pick out faces and photos, but it can't write a poem.
Exactly. Or your virtual assistant, it can answer questions, set timers, play music, but it can't, discover a new law of physics. Self-driving cars are amazing at navigating roads.
But they won't negotiate your mortgage. Got it. Super specialized, astonishingly good at one thing, maybe a few related things, but that's it.
Precisely. No matter how complex or impressive it seems in its domain, it's still mimicking a slice of human intelligence. It doesn't have general understanding, common sense, or the ability to transfer its learning easily to a totally different task. It's bound by its programming and its training data for that purpose.
All right, so that's narrow AI, the reality today. Let's see the one, the dream, you call it, the sci-fi stuff.
That would be artificial general intelligence, or AGI. This is kind of the holy grail for a lot of AI researchers.
AGI sounds familiar. That's the one where machines are basically like us, right?
Pretty much. AGI refers to machines with human-level cognitive abilities across the board, capable of understanding, learning, and applying intelligence to solve any problem, not just one specific task. Think learning any skill, adapting to any environment, reasoning abstractly, maybe even having consciousness or emotions.
So HAL 9000, data from Star Trek, that kind of thing. Robots that can do anything a human can do, mentally speaking.
That's the concept, yes. And this is really important. AGI does not exist today, period.
Okay, good to get that clear. So, despite all the amazing progress, we haven't built anything close to a truly human-level intelligence?
Not even close. We're still firmly in the era of narrow AI. AGI is a fascinating goal, incredibly ambitious, but it involves overcoming massive scientific and philosophical hurdles. It's way off in the future, if it's even possible.
Okay, so we're not quite at the Terminator level yet, thankfully. Phew, that's a relief. But hang on. If most AI is narrow and isn't really thinking like us, then how does it learn to do all these incredible things we see? Like recognizing speech or playing Go better than any human. What's the actual mechanism? How does the learning happen?
Now we're getting to the engine room. The magic, as you put it, is mostly down to a field called machine learning, ML for short.
Machine learning. Heard the term a million times, but what is it? Like, really? Are we sending robots to school?
Huh. Not quite like that. Think of it this way. Normally, you program a computer with explicit instructions for every single step. With machine learning, it's different. It's a set of techniques that let an algorithm, the computer's instructions, actually change its own behavior and get better at a task over time.
How? By itself.
By learning from data and experience. Instead of coding every rule for, say, identifying spam email, you show the machine thousands of examples of spam and not spam emails. It starts to figure out the patterns on its own.
Okay, wait. So it's like teaching a kid. You don't list every single feature of a dog. You just show them lots of dogs, and eventually, they just get it.
That's a fantastic analogy,
Yeah.
exactly. The algorithm tries something, sees if it worked based on the data, makes adjustments, and tries again. It learns from errors and successes, constantly refining itself without a human explicitly reprogramming it for every tiny variation.
So it's learning from mistakes, but like super fast. That does sound powerful. It's not just static code anymore.
Right. It's dynamic. And there are a few main ways machines learn within this ML framework. Different strategies, you could say.
Okay, I'm intrigued. What are these learning styles?
Well, the most common one you probably interact with is supervised learning.
Supervised,
Yeah.
like someone's watching over its shoulder?
Kind of.
Yeah.
In supervised learning, the AI learns from data that's already been labeled by humans. So going back to the spam example, each email in the training data is already marked spam or
Right.
not spam. The AI learns the relationship between the email content and that label.
Okay, so you give it the questions and the answers to learn from. Like flashcards.
Exactly like flashcards.
Yeah.
Training an AI to recognize faces in photos. You feed it millions of photos where humans have already drawn boxes around the faces and labeled them face. The AI learns the patterns associated with that label.
Hold on. Those annoying prove you're not a robot things online where you have to click on all the squares with traffic lights or bicycles.
Uh-huh.
Are we labeling data for AIs when we do that? Like free labor.
Chuckle slightly. You absolutely nailed it. Those ChatGPT often serve that dual purpose. They check you're human, yes, but you're also helping to create the massive labeled data sets needed to train things like self-driving car perception systems, millions of people clicking on traffic lights.
Wow. Okay. Mine's slightly blown. So that's supervised learning. What else?
Then you have unsupervised learning. Here, the AI gets data with no labels, just a big pile of raw information.
So what does it do then if there are no answers?
Its job is to find structure within the data all by itself, to discover hidden patterns or group similar items together. Imagine giving an AI thousands of customer purchase histories without any labels. It might automatically group customers into different segments based on their buying habits, like bargain hunters, luxury shoppers, weekend die-ers, without ever being told those categories exist.
So it finds the groups on its own. That seems smarter in a way, more independent.
It's very powerful for discovering things you didn't even know to look for, finding hidden correlations in scientific data, clustering news articles by topic, that kind of thing.
Okay. Supervised with labels, unsupervised finding patterns. Is there a third way?
There is reinforcement learning. This one's more about learning through trial and error, kind of like how animals learn.
Trial and error, like just guessing until it gets it right.
Sort of, but it gets feedback. The AI takes actions in an environment, and then it receives rewards or penalties based on the outcome of those actions. Its goal is to figure out the sequence of actions that maximizes the total reward over time.
Okay, give me an example.
Think about an AI learning to play a video game. It makes a move. If that move gets it closer to winning or earns points, it gets a positive reward signal. If it gets hit by an enemy or makes a bad move, it gets a penalty, a negative signal.
And over millions of tries, it figures out the best strategies just by chasing the reward.
Exactly. That's how AI's mastered complex games like Go or chess, beating the best human players. It's also used a lot in robotics, teaching robots how to walk or manipulate objects by rewarding successful movements.
Wow, okay. Supervised, unsupervised reinforcement. 3 ways machines learn. That makes a lot more sense now. But I keep hearing another term everywhere, deep learning. Is that like extra strength machine learning
Oh,
or
yeah.
something different?
That's a great question. Deep learning isn't separate. It's actually a very powerful type or subset of machine learning. It's become incredibly important in recent years.
A subset. So it uses those same learning principles.
Yes, it often uses supervised or unsupervised methods, but its defining feature is its structure. Deep learning relies on something called artificial neural networks with many, many layers. That's where the deep comes from.
Neural networks,
Yeah.
layers, trying to mimic the
Uh,
brain.
That was the original inspiration, yes.
Mm.
Think of these networks as layers of processing units, kind of like neurons. Information flows through these layers. The input data hits the first layer, gets processed, the result goes to the next layer, gets processed further, and so on, through maybe hundreds or even thousands of layers.
Layers upon layers. What does that do? Why so many?
Each layer learns to recognize patterns at a different level of abstraction. Imagine feeding it images. The first few layers might just learn to detect simple things like edges or corners.
Okay.
The next layers might combine those edges to recognize basic shapes, like circles or squares. Deeper layers combine those shapes to recognize more complex features, like eyes or noses. And the final layers might put all that together to recognize a whole face or a specific object, like a cat.
Ah, so it builds up understanding step by step, from simple features to complex concepts, all automatically.
Precisely. This hierarchical feature learning is what makes deep learning so incredibly effective at tasks involving complex, unstructured data like images, sound, and natural language. Remember that famous example where Google's AI learned to recognize cats just by watching millions of YouTube videos without ever being explicitly told this is a cat?
Yeah, I remember that.
That was deep learning at work. Those deep neural networks figured out the essence of catness all on their own from the raw pixel data.
So these deep layered networks are behind a lot of the really impressive AI we see now, image recognition, speech translation. This leads perfectly to those amazing chat AIs, the ones everyone's talking about. How do they fit into this? How do they manage to write emails, poems, even code?
Excellent transition. Those chat AIs, the ones generating text, are mostly powered by large language models, or LLMs. And yes, they are a prime example, a really spectacular application of deep learning.
Okay, so LLMs use deep learning, but what makes them specifically language models?
Think of an LLM like, imagine an absolutely immense library. But not just books, every website, every article, every transcript, every conversation, tons of code, billions of text snippets from everywhere, all digitized. Now imagine a librarian who hasn't just cataloged it, but has read and processed every single word of it.
Okay, that's a lot of reading, unimaginable amount.
Exactly. And from reading all that, the LLM learns the patterns, the probabilities, the statistical relationships between words, phrases, sentences, concepts across all that text.
So it knows how language works because it's seen pretty much all of it.
It knows how language statistically works. And this is the absolute key thing to grasp about LLMs. They don't understand language or concepts the way humans do. They don't have beliefs, intentions, or consciousness.
Wait, they don't understand. But they seem like they do. They can explain complex topics. They can sound empathetic.
It's an incredibly convincing simulation, but underneath, an LLM is fundamentally a master pattern predictor. It's exceptionally good at predicting what word is most likely to come next in a sequence, based on the context and everything it learned during training.
Predicting the next word, that sounds too simple for what they can do.
It sounds simple, but when you do it based on trillions of examples, the results are astonishingly complex and coherent. Think about it. An LLM doesn't feel sadness, but it's read millions of texts where words like cried, heartbreak, loss, grief appear together in context described as sad. So if you ask it to write something sad, it doesn't feel sad. It predicts the sequence of words that statistically correlate with sadness based on its training data.
Okay, so it knows sad words go together, but not the feeling itself.
Exactly. Or it doesn't intrinsically know a dog is loyal, but it knows that in countless texts, the phrase man's best friend is overwhelmingly completed with dog, and that words like loyal, faithful, companion appear very frequently near the word dog. It's all statistical correlation, incredibly sophisticated pattern matching.
That is a fundamental difference. It's like a mimic, an amazing statistical parrot, not a thinking entity.
That's a good way to put it. An incredibly advanced parrot that's read the entire internet. And recognizing this distinction is absolutely crucial for using them effectively.
Why crucial? Because if we think they understand, we might interact with them incorrectly.
Precisely. If you assume understanding, you might ask vague questions, expecting it to grasp your underlying intent like a human would. But it can't. It only has the words you give it. This also helps explain why they sometimes hallucinate, make things up confidently.
Yeah, when they just state something completely wrong as if it's fact.
Right. It's not lying. It's predicting a plausible-sounding sequence of words based on patterns it learned, even if those patterns don't correspond to reality in that specific instance. Its goal is coherent text generation, not necessarily factual accuracy, unless specifically guided.
So it's filling in the blanks with the most probable words, even if those words create a fiction.
Exactly. Which leads us to a really important point. If these incredibly powerful systems don't truly understand us, if they're just predicting patterns, how do we actually get them to do what we want them to do? How do we reliably get useful, accurate, desired outputs?
That's the perfect question. If they're these amazing engines but don't think like us, how do we steer them? How do we become the pilot of the AI instead of just a passenger hoping it goes somewhere useful? That sounds like a skill in itself.
You've hit the nail on the head. That skill, that practice, is what we call prompt engineering.
Prompt engineering. Okay, I'm hearing this term everywhere now. It's not just about asking a question anymore, is it?
Not at all. It's evolved way beyond that. Prompt engineering is really the art and the science of designing your input, your prompt, in a way that guides the AI model precisely towards the output you need. It's about crafting instructions that are clear, specific, context-rich, and structured.
So it's like learning the AI's language, not code, but the language of instruction.
Exactly. It reminds me of that story about Jacob Handel you mentioned earlier, realizing the frustration wasn't the AI's fault, but came from giving it bad, vague instructions. The shift is from just asking to actively designing the input.
Designing the input. Okay, I like that. It sounds more deliberate, more strategic.
It is. It's about telling the AI not just what to do, but how to do it, what persona to adopt, what tone to use, what format the output should be in. You're providing a detailed blueprint, not just a suggestion.
Can you give us a concrete example? Like, show the difference between a weak prompt and a really well-engineered one. Does it really change the result that much?
Oh, absolutely. The difference can be night and day. Let's take a simple example. A weak, deficient prompt might be, write something about the importance of creativity.
Okay, yeah, I can already imagine the output. Probably boring, generic, full of platitudes, totally forgettable.
Exactly. You'd get maybe a grammatically correct paragraph, but zero impact. Now contrast that with an optimized prompt. Listen to the level of detail. Act as a legendary creative director, channeling the spirit of Steve Jobs in his prime. Write a short, powerful manifesto, maximum 150 words, aimed at young entrepreneurs. The goal is to inspire them to challenge conventions and embrace radical innovation. Use direct, provocative language, short sentences, and an energetic, rebellious tone. End with a single, challenging question that makes them rethink their approach.
Wow, okay, that is different. The first one is like asking for a noise. The second is asking for a specific symphony. You're giving it a role, a target audience, a word count, a style, a tone, even the structure of the ending.
Precisely. You're leaving nothing to chance. You're guiding the AI's statistical prediction engine down a very specific path. And the result will be vastly different, far more targeted, useful, and aligned with your actual goal.
It's like programming with natural language almost.
That's a good way to think about it. And to do it effectively, it helps to understand the anatomy of a great prompt. There are key ingredients.
Anatomy. Okay, like what are the essential parts?
First, there's the context or role. This is where you give the AI a persona, a job title, a specific hat to wear.
Like in the example, act as a legendary creative director.
Exactly. Or you are an expert travel agent specializing in budget backpacking. Or assume the role of a skeptical scientist reviewing this paper. This immediately focuses the AI, telling it which part of its vast knowledge base and which stylistic patterns are most relevant. It sets the stage.
Okay, makes sense. Give it a job. What's next?
The instruction or task. This is the core command, the main verb. What do you actually want the AI to do?
Like, write a manifesto, generate 5 blog post ideas, summarize this text, translate this into French.
Precisely. It needs to be clear, direct, and unambiguous.
Yeah.
Tell it the action to perform.
Got it. Context, instruction. What else is key?
Style and tone. This is absolutely crucial for getting output that feels right. How should it sound?
Ah, like the energetic, rebellious tone in the example, or maybe professional and formal, or funny and conversational, or empathetic and supportive.
Yeah, exactly. You define the voice, the personality, the mood. Do you want it witty, serious, academic, casual? Specifying the tone ensures the output resonates correctly with your audience or purpose.
Okay, that's huge. And then I guess how you want it presented so you don't just get a giant block of text.
Right, that's the format. How should the information be structured? In bullet points, a numbered list, a table with specific columns, a JSON object, short paragraphs, a formal report structure.
Ah, okay. So you can say, present the results in a table with columns for pros, cons, and recommendation. No more wading through dense text.
Exactly. It makes the output immediately more usable. Define the structure you need.
Context, instructions, style, format, anything else.
One more powerful element, especially for complex tasks. Examples, sometimes called few-shot prompting.
Examples, like you show the AI what you want.
Yes, instead of just describing it, you give it one or two concrete examples of the kind of output you're looking for. If you wanted to write marketing copy in a specific style, give it an example of copy you like. If you need data formatted in a certain way, show it an example row.
So here's an example of a good subject line. Now write 5 more like this.
Perfect example. Showing is often better than telling. The AI picks up on the pattern, the style, the structure from your example much faster and more accurately than if you just tried to describe it in words. It really helps nail the nuances.
That makes so much sense. Context, instruction, style, format, examples. It's like building a complete specification for the AI. Okay, but what about really tricky stuff? Like problems that require multiple steps of reasoning or where the AI needs to, think it through logically. Can prompting help there too?
Absolutely. That's where we get into more advanced prompting strategies, moving beyond just single instructions. One of the most impactful is chain of thought prompting, or COT.
Chain of thought. Does that mean you make the AI show its work, think out loud?
Pretty much, yeah. For
Yeah.
complex problems, math problems, logic puzzles, multi-step planning tasks, just asking for the final answer often leads to errors. The AI might try to jump to a conclusion too quickly.
Right, I can see that happening.
So with chain of thought, you explicitly instruct the AI to break down its reasoning process before giving the answer. You literally add phrases like, think step by step, or let's work this out in a step-by-step way to ensure we have the right answer, or explain your reasoning first.
Ah, just like my old math teacher used to say, show your work. And that actually makes the AI more accurate.
Significantly more accurate for these kinds of tasks. It forces the AI to follow a logical progression, reducing the chance of it making leaps of faith or calculation errors. It makes its reasoning transparent and helps it arrive at the correct conclusion more reliably.
Okay, that's a clever trick. What other advanced techniques are there?
Another key one is iterative prompting, recognizing that the first output you get is rarely perfect.
So it's more like a conversation, a back and forth, not just one shot, one prompt.
Exactly. Think of it like sculpting. You don't get the final statue with the first hit of the chisel. You start with a prompt, get a result, analyze it, and then give the AI feedback or refined prompts to improve it.
So I might say, okay, that's a good start, but make the tone more enthusiastic, or can you expand on point number 3, or replace the examples with ones relevant to the tech industry?
Precisely. It's a dialogue. You refine, clarify, steer the AI through multiple terms until the output is exactly what you need. Don't settle for the first draft. Iterate.
I like that. It feels more collaborative, less like ordering from a machine, more like working with it. What about learning from really good AI outputs? If I see something amazing, can I figure out how it was made?
Yes. That leads us to reverse prompt engineering. This is a really neat technique.
Reverse engineering the prompt. How does that work?
You take a piece of AI-generated content that you find impressive, maybe a really well-written email, a stunning AI image description, a clever piece of code, and you feed it back to the AI.
And ask it, what?
You ask the AI to act as an expert prompt engineer and analyze that content to deduce the likely prompt that generated it. You're essentially asking, what instructions would create this result?
Whoa. So the AI helps you figure out the recipe for success. That sounds incredibly useful for learning.
It is. It helps you understand the components, the likely role, instruction, style, keywords that led to that high-quality output. It's a fantastic way to level up your own prompting skills by learning from great examples.
Chain of thought, iteration, reverse engineering. It really is an art form. It's not just about typing a question. It's about structuring a whole interaction, guiding the AI. It truly does feel like moving from being a passenger to being the pilot.
Pilot, architect,
Yeah.
collaborator. Yes. And thinking about it that way elevates the prompt beyond just a set of instructions.
Right.
Some people talk about the prompt as a vector of
They
intentionality.
have a vector of intentionality. Okay, unpack that one for me. Sounds a bit abstract.
Think of the LLM's vast knowledge space, all those connections and patterns it learned as this enormous high-dimensional space of possibilities.
Mhm.
A vague prompt like write a story is like pointing a dim, wide flashlight into that space. You'll illuminate something, but it'll be fuzzy, generic, unfocused.
Right, you get a random story.
But a well-crafted prompt, using all those elements we discussed, context, instructions, style, format, maybe even examples, acts like a powerful, fine-tuned laser beam.
Ah, okay, a laser beam, much more precise.
Exactly. Every word choice, every constraint you add, adjusts the direction and focus of that beam, guiding it to a very specific point within that vast space of possibilities. It allows you to precisely target the exact kind of output, the specific location in the knowledge space that aligns with your intent. Your prompt becomes the vector directing the AI's focus.
I like that analogy, the laser beam of intent. It really highlights the need for precision, which actually makes me wonder, to be that precise with the AI, doesn't it mean we have to be really, really clear in our own heads first?
You've just hit on perhaps the most profound side effect of mastering prompt engineering. The AI, in many ways, acts as a perfect mirror reflecting the clarity of your own thought.
A mirror. How so?
Think about it. If you get a vague, confused, or unhelpful response from the AI, your first instinct might be to blame the AI. It's not smart enough, didn't understand. But 9 times out of 10.
Uh-oh. I have a feeling I know where this is going.
The fuzzy output is because the input, your initial idea, your own internal request, was fuzzy to begin with. The AI can only work with what you give it. If your concept is half-baked, the prompt will likely be weak, and the output will reflect that lack of clarity.
So struggling to write a good prompt is actually a sign that I haven't fully fleshed out my own idea yet. That's
Yeah.
fumbling and actually really useful.
It's incredibly useful. The very process of sitting down and forcing yourself to articulate a detailed, structured prompt, defining the role, the task, the tone, the format, compels you to engage in metacognition, thinking about your own thinking.
Right. I can't ask it to explain quantum physics simply if I haven't first figured out which specific concepts I want explained and to whom.
Exactly. You have to clarify your goals, your audience, your desired outcome before you can effectively instruct the AI. It can't read your mind, it reads your prompt. So prompt engineering isn't just about getting better AI results. It's a powerful forcing function for improving your own clarity, critical thinking, and communication skills. It's like a workout for your brain.
Wow. The AI as a mirror for my own thoughts. That's a really cool insight. Okay, so we're collaborating, we're refining our thinking. Can we take it even further? Can we make these AIs feel even more like our specific partners? Like, can we sort of train them on the fly to be our dedicated assistant for a particular project or style?
Absolutely. That's where calibration prompts, sometimes called Genesis prompts, come in. This is about setting the stage for an entire conversation, not just a single turn.
Calibration, Genesis. So like setting the starting rules for this specific chat.
Precisely. It's like giving the AI its core operating instructions for your interaction right at the beginning. You define its personality, its role, its specific skills, its constraints, its goals for that entire conversation.
Can you give an example? How would that look?
Sure. Imagine you're starting a new chat session to brainstorm marketing ideas. Your very first message, the Genesis prompt, could be something like, "Okay, new project. For this entire conversation, you are Sparky, my ultra-creative, slightly irreverent marketing brainstorm partner. Your expertise is in viral social media campaigns for Gen Z. You always provide 3 distinct ideas per request, formatted as bullet points, with a catchy headline for each. Your tone should be enthusiastic and unconventional. Always challenge my assumptions and end your responses by asking, what if we push that even further? Let's start."
Whoa. So from that point on, in that specific chat window, the AI is Sparky. It maintains that persona, that format, that way of interacting.
Exactly. Every subsequent prompt you give in that conversation is interpreted through the lens of that initial calibration. You're no longer talking to a generic LLM. You're collaborating with Sparky, your custom-tuned brainstorming assistant who already knows the rules of engagement.
That is incredibly powerful. It's like creating a bespoke AI team member for every specific task or project just by setting it up correctly at the start.
It transforms the interaction.
Yeah.
It moves from single transactions to an ongoing, stateful collaboration with an AI partner calibrated precisely to your needs. It's a much more efficient and personalized way to work with these models. Hashtag outro.
Wow. What a journey we've been on today, seriously. We started with the big picture, like what even is AI? Then we dove into how it actually learns machine learning, deep learning, all those layers. And finally, mastering the conversation with prompt engineering. It feels like we've gone from just being users to understanding how to be, I don't know, architects or conductors of AI.
It's a shift in perspective, isn't it? From seeing it as a magic box to understanding the levers and dials.
Mm-hmm.
And speaking of architects and prompts, we've spent all this time talking about how crucial a good prompt is, how it defines and shapes the AI's output, how precision leads to better results. Well, it makes you think, doesn't it?
Yeah.
Connecting it back to us, to our own existence here. Were we created with a good prompt?
A beat. That is definitely a thought to chew on. Very meta thought to end on. Okay, everyone, go out there, experiment, engineer some amazing prompts, and create something extraordinary. Thanks for diving deep with us.